Decomposition. Right, let's be honest here. It's absolutely gross. What do we mean by decomposition? When do you use it in normal life? You think about things like dead bodies and compost and things like that. Things that are being broken down into their smallest possible elements. And that's what we're going to do when we're going to decompose functions. For instance, if we have example 13 here, there's many different elements, things that are happening to x's. Many different things that are happening to x's in function h of x. And we could break h of x down into much smaller operations. And we're being told in the question to break it down into just two functions, f of x and g of x. To be honest, this one could be broken down into more than just two functions, but let's look and see what we've got. How I would consider decomposing a function is starting from the outside and working in. It'd be like, have you ever peeled an onion and you can sort of peel off layers outside the onion until you end up with something in the middle. So when I look at this function, I can see that a math thing that's happening from the outside in. Can you see you've got a lump, an ugly lump in the middle that's being squared? That would be your outer function. If we look up here, let me get my pen. Let's choose, we're on red. If we move up here, can you see that the outside function has to be f? What's happening here is we have got, oh, good grief, why is my pen not working? We've got f of something. And what's happening on the outside here? Sorry, this is really not working for me right now. It's something being squared. Let's erase all that because it's a horrible mess. Okay, so the function on the outside, when I look at it, I'm seeing that f of x is something squared. What's our input? It's x. Doesn't matter that this bit in here is more than x. We're just saying the function on the outside gets some input and squares it. And what's got to be in the inside? On the inside has to be g of x. Okay, so this inside, everything inside, so all of this must be what g of x equals. So g of x must be x plus 1 divided by x. That is not the only way that this could have been broken down. This could have been, somebody else could have said, well, when I look at this, I look at it from the inside going out. And I see I've got a fraction. I've got something divided by x. So many different ways to do these problems. I prefer to do them from the outside in. Let's see what we did in the past. Oh, yay, matches what I did last time. Double check what we've done. If you go back, say, right, my question said, write f of g of x, f of g of x. Mine would be f is something squared. What I've got on the inside, g of x, and I've said g of x is x plus 1 over x. When I put it together like that, my question said, make that be h of x equal that. Here's what I've just written here, h of x. Yay, it is. So that's function decomposition. There's many ways to do this. I prefer coming in from the outside in. But other people teach you to come from the inside out. It doesn't really matter. You can do it both ways. So try this one. Try it on your own. There are several correct answers for this one. Let's see what you get. So pause your video and give it a go. Right, when I look at this, I'm seeing a fraction with some ugly lump being divided by 3. So whatever's on the outside, and look, it's telling me, I need a pen now, not an eraser. It's telling me that on the outside, I've got f. And when I look at this, I see something being divided by 3. And that's got to be what I'm seeing from the outside looking in. So my f of x is going to be my something, my input. What do we always call the input in these? We call it x. Okay. And then what's the inner function, if I strip away divided by 3, what am I being left with? I'm left with my g of x. So my g of x must be, what was in the top of this fraction? All of that. It's the square root of x minus 1. Oh, this mouse is a funky angle, isn't it? Okay, somebody else might have done this totally differently. Somebody else could have looked at this problem. So that's one correct answer. One correct answer is, let's get rid of that there. That would be a pair that would go together as one correct answer. There's other ways. Somebody else could look at this from the inside out and say, the first thing I'm going to do is I'm going to take the square root of something. And then what's on the inside, they're looking from the inside, so that would be g of x. So your g of x could be, I'm going to take the square root of No, that wouldn't work that way, would it? That would have to be my f of x, and it'd have to be on the outside and say I've got the square root of something divided by 3, and on the inside, what does this need to be replaced by? That would give me my g of x is x minus 1. If I put those two together, does it work? If I'm doing f of g of x, my f of x is the square root of something divided by 3, and my g of x is x minus 1. That one works. Go back and look at this one. My f of g of x, if I do this combination here, I'm saying my f says get your input and divide it by 3. What is my input? G of x. What does g of x look like? X minus 1. Both of those would work. It's almost complicated, overcomplicated, because they only made you break it down into 2 functions. This whole lot could have actually been broken down much more easily into 3 functions. We could have called the whole function m of x and say it's f of g of h of x. The very inside bit would be this. Then we're taking the square root of that, and then we're dividing by 3. Those would be your 3 functions if you broke it down that way. That's all I can say about this one. So let's stop this video. And I'm never going to watch it again, because that was not one of my better ones, if I can find the stop.